Smooth STL-based compensation. In NX additive manufacturing, the build plate is prepared for printing and simulation. From additive manufacturing, we switch to advanced powder bed fusion, where a thermomechanical simulation is created using a stainless steel material. Thermal slices and relatively coarse mechanical slicing are defined to create the FEM mesh using the automatic meshing algorithms. The user can choose the computation options and multiprocessor setup for the simulation. The process simulation will run fully automatic, after which the temperatures and distortions can be post-processed using the different post-processing capabilities. With the new STL-based compensation, the user will select the load case and the resolution of the exported STL file. The deformed STL file is derived from the CAD geometry and the smoothness no longer depends on the element size. The compensated specimen must be loaded into a new part file as a convergent model. The user can still make changes via polygon modeling. For example, one can create B-rev surfaces with serial numbers. To add the support STL, the user must switch to modeling and read the supports as NX bodies. After switching back to additive manufacturing, a user-defined support must be created using the faceted supports. The new additive manufacturing part with a compensated model is now ready to be sent to the printer.